in general.
Hello my dear friends and welcome back everybody. How it's going? So today, as for myself, I'm spent all my day working on the documentation for the new RoadRunner release. I remember that we are going to release a new 2023 RoadRunner version, I guess in the next 2 weeks, somewhere around when I finish the documentation. So basically all the code at the moment is ready, and the documentation is like the rest, the nail to release, the last nail. So yesterday we did a very interesting thing. We compared Rust performance and especially like a Gorge without attaching anything to Rust, especially process, and we compared the thing with Go already working Go code. So, and Go as expected was slower a little bit, like approximately from 10 to 15%, But this is not very significant, like speed improvement from the Rust side. Moreover, for example, we have a lot of things which I currently and which we stopped yesterday from implementing. So I'm not sure how to implement in Rust various things. Let me open the RoadRunner in Rust. Yes, so yesterday, yeah, this is basically the test. And I figured out that we also have a nice thing in Rust called task, like Tokyo task. Tokyo task is basically, as they state, lightweight, non-blocking unit of execution. So it's similar to goroutine. But if you use a goroutine, so basically you don't have any borrow checking rules in Rust. I'm sorry, in Go, but especially in Rust you do have. And the current problem that we basically can do like this. We can't just run Tokyo task and spawn this green thread and run something like this. Especially if we use some kind, so basically if we use some kind of transitions, yeah, we can do this by implementing send and sync. Well, this is not a problem for us, because yeah, if we implement send and sync, we can basically use it across different threads. But which is more important, that we have things. Let me show you. Like this. Oh, sorry, not here. Like here in Worker Watcher. Like this one. Wait. So basically, what is wait? Wait is waiting for the worker to complete. So, for example, if let me open my R node. Where is our Rust plan? So basically, if we have something like if we need to wait in different thread, so this is like a goroutine, in Go. So this is like running in different goroutine while we executing using a other function of worker. So both of these are worker. So this is the same structure, worker. And basically, what is in Rust and what is interesting in Rust? So basically, both of them are mutable. This one is mutable and this one is mutable. Basically because we just can't pass, for example, here in Gorich, we're acquiring this as mutable reference to self, because we can't, because wait child is mute self, so we can't like bypass this rule. So because so this implemented like this in standard library, we just can't do this in a different way. And which is more interesting, so in Go we can, in Go we don't have these rules, so we don't have this mutable things. So as a Go compiler, like, okay, so if you write this, if you wrote this, it's okay, it's fine, you can run this. And basically we do this like this. So we just run in this wait function like this one in a different goroutine. So, and this function blocks. This function, which is more interesting, this function blocks until this process exited. And this is very important for us to do things like this. Give me a second. Okay, so I need to answer. Basically, so in Rust, we just can't do like this. We can't start a thread here like this, wait, routine like this one, and at the same time, like work with these workers like this. Where is it? Where's our pool? Static pool and static pool, yeah, and where's exec function. So, and basically we are getting the worker like here, take worker, and here you are. This is our worker. I'm sorry. Yeah, so this is our worker, and basically this worker is mutable because we can change state on it. We can change process exit status. So basically, this worker have a lot of fields which we can change. Yeah, and this worker is mutable as well, like this. Like for example, exec. So I tried to ask a ChatGPT. I tried to read the books yesterday. I tried to find information about this. So basically, we have a pattern called internal mutability, but this pattern doesn't save us from like doing what we're trying to do, like to access both in a mutable way. As far as I understand, we can also learn a little bit more about this, like Rust book, interior mutability. So yeah, so allows you to mutate data even when there are immutable references to this data. So this is very important. We have two mutable references, you know. So if we would have one reference which is like immutable, and the second one is mutable, so in this case, I guess we can apply this rule, like by introducing like ref cell, like this. Yeah. So we have a mutable reference. Yeah, we can borrow as mutable. Yeah. And so also we basically can't use a mutex here because in our Go SDK here we don't need this, we don't need worker test protocol. Yeah. So here when we add to watch, so I guess here, yeah, so here we just iterating over all of our workers, and by their repeat adding them to watch, and basically add to watch means just start routine with this wait worker base. So this is definitely not how Rust works. In Rust we just, so this is so unsafe in terms of Rust, because we, you know, while we iterating, we adding like a mutable reference, we're calling a method with mutable reference to the workers which we are iterating. So in this case we are, due to Rust external linter, don't show this again. So in this case, basically, we have two. This is like representation of interior mutability pattern, you know. So while we have automatically applied, you know, so we have basically workers, which is immutable reference, and this add to watch is mutable reference. So in Rust, definitely this is not possible. And I know we have to revisit everything, and we have to rewrite this in a different way. And I don't know how to write this, so we will think here on the stream how to do this, because basically this is the very important function in Go, because we can just like call wait for a system call directly without like all of these structures. Yeah, so we can just do where is it, wait, blocking wait, user status. Yeah, this is called wait for. We can just do like this, and basically we can do this knowing only PID of our child. And since we're calling wait for from a parent process, this is allowed by Linux or by any platform to call wait for if you are parent for the child. So he will block until the child exited. If you call this for a different imagine that you have a process which is not a parent of yours, and you'll call wait for, you'll exit immediately, because you can't do wait for on processes which are not your child's. Okay, so and in our case here we can do this directly. So in this case we only need to know only PID. But this involves other problems. First of all, we have to support like wait for and all other like wait system calls for all of the platforms like Windows, macOS, Linux. So if for Linux is this approach is quite easy to achieve, like this is just wait for, it's very easy. So for Windows, I don't know wait for Windows. Do they have something similar? Oh, they also have like wait for. No. Seems this is about Linux. Oh, wait PID. Maybe they have. Oh, no. So wait PID is Linux. So you see, we have to support different like waits per platform, and I don't want to do this actually. So since we already have this wait system call, we can for sure we can okay, so we have option to write like system call, or also I tried to like split stdin on the child, so and tried to like using a wait and on on the different processes, and using like stdin as like a field. Like, okay, so if you don't want to share a child with me, like, could you please share a field of this child with me? But yeah, so I can't fool Rust in this way. So Rust is like, no, you are trying to fool me, young man. Or old man, I don't know. So yeah, so as you see here, yeah, I can add mutable, yeah, for sure, but still this will not save me. Yeah, yeah, so this is just a hidden error message that you can't use this. Okay, so we can, okay, let's leave it open. So this is what happened with your Rust code when you're trying to design it like Go. So it will not work. So why wait is so important for us? I'll just show you our worker watcher. So this function is, I know it's one of the main functions in the RoadRunner, because in this function we are blocking until the process exited. And this is very important because for example, out of memory killer can kill our worker, or a user can by purpose kill our worker, or PHP can die, or so anything can happen. And we have to track this, so we can't allow to execute something or to continue pushing workers from the pool to user while we have this situation when some of the workers died. And user can have 100 workers, for example, and I don't want to search them in this stack, because we don't have a function to remove from stack. This function is just from our workers. It's just a different data structure. This is not our stack, but in stack obviously we don't have this. And and we also have to track the states. So if, for example, OM killer killed our worker, we actually don't want to leave this worker killed. We just want to reallocate it. And if we detect that state is not destroyed, but state destroyed can set only RoadRunner on this process. So this is our internal finita state machine. So, and if the worker is not in this state, that means that someone from outside or from inside, like PHP, killed our worker, and we have to relocate it. So in this case, this is just impossible to kill RoadRunner workers. So if you didn't kill the RoadRunner itself. So in this case, you can just kill everything, nuke everything, and runner will reallocate continuously all of these dead workers. And this is why this function is so important for us. So we have to block on something, and we have to have some kind of messaging bus to know that the worker died. So this is one of the approaches. Another approach is to check. So every time we get the worker from the pool, we can check if it's alive. In Rust, we have this function called self. Let me check. The child is try wait. Yeah, we can try wait, but yeah, this is not what I want to do on the child. Let me check here. Self. I guess we should have some kind of function oh, it's on wait. Oh, so we can check this. So another way I expect it to be that we can somehow check. Hello, the Arch. Yeah, sure. So the project called RoadRunner. So this project is basically this our organization. So this is a server for the PHP applications written in Golang and with a lot of plugins. So basically we work on a Golang application, not on the PHP applications. We have a lot of fun things here, like our custom protocol to communicate between PHP and Go via pipes, via process pipes. So kind of low-level thing. We have our algorithmic container endure code, like called endure. So this is it's used for combine all of the plugins and communicate between plugins. So we have a lot of things, SDK, and it's like a general thing. And we have a lot of plugins here. Like this is general work. So our organization is open source, and I basically work on open source things. And on these streams, basically I'm trying to rewrite RoadRunner in Rust. So we already rewrote Gorich. Gorich is our protocol. You may find it here, like this one. So this is like how protocol looks like, and yeah, we did all of the things in Rust, but at the moment, I guess I faced with an error when I can't use the Go approach. So we did basically one-to-one copy from Go codebase to the Rust, but basically we can't apply some patterns, which is like very common in Go. We can't apply them into Rust. For example, the pattern here states that in Go you can have a lot of mutable references to some objects, like everyone can get a mutable reference to a slice, so nobody care about this. In Rust we can't do like this. We can have on or mutable reference or immutable reference. We can't have like two or we can have like immutable references provide to everyone, but we can't have at the same time two mutable references or mutable reference and immutable reference. And basically here my problem that where is it? Yeah, so in this place, when we already did everything related to worker, so worker, basically this is a process, it's just like called worker. So this is just general Linux process. So inside this process we run a PHP script, and the problem is that I started to apply the patterns, Golang patterns, and I can't do this in a very straightforward way, So I can't do this. I can't execute a payload on this process, so I can send the data inside this process and wait, calling wait for system call at the same time, like we did in Go. So in Go, basically we have two mutable references to the same object, like in wait and in the execute. So we have two mutable references, but in Rust we should have or mutable or immutable and apply intermutability pattern, or have only only immutable references to this data objects. But we can't do like this. So since our, for example, wait, as you may see here, wait is mutable. And also exec function, when we send via pipes, so this is just like inter-process communication thing. And when we send the data to the stdin, to this process child stdin, so we also can't do this in immutable way, because we have to get a mutable reference to it, because write all function also mutable. So this leads us to I don't know, to choices. How we can do this in Rust? So we can either implement wait for by ourselves and implement wait for every platform which RoadRunner supports, or we should find a way how to use two mutable references at the same time. But this is impossible, I guess. I don't think that if we don't want to get into unsafe, this is even possible in Rust. Or the third option is we have to like rewrite everything in some way, in some Rust way, you know. So this is basically the problem. And you know, it's kinda not easy to solve. I don't want to nuke everything here, and I also don't want to check every time I call exec. I don't want to check if this process is alive. And basically we don't have anything, any like, you know, any fields or any methods to check if it's alive. Like for example, where is it? Oh yeah, self pipes child. Yeah, so we don't have any like anything in the standard libraries that help us here. So basically this is the problem. And I tried to ask ChatGPT, so this is kind of general nowadays, you know, to ask ChatGPT to solve this problem. So ChatGPT, could you please solve this problem? And ChatGPT, you know, ChatGPT exits from the chat. So I tried like for half of the hour to just to like ask and provide a different way, provide a different like notes to the ChatGPT to solve this problem. So, but ChatGPT like just okay. So I hang out, and I can solve this problem because it's basically. I think this is not how Rust works at all. I'm not very proficient in Rust, you know. Since I looking at Rust for a long time, but I don't have a lot of production experience in Rust. So I wrote a few algorithmic libraries, but algorithms is kind of easy to implement in Rust, you know, because algorithms is, you know, the stuff that can be easily implemented by any programming languages if you know the algorithm itself, you know. So I implemented a lot of them, like here. So basically like hundreds of them in Rust and in Go. So in Rust basically this is kind of easy to do. So I mean algorithms, so because they use a very basic building blocks like vectors, reference cells, you know, options. So this is kind of easier to solve. But now we have a real production problem. Okay, Google. How I can use two mutable references in Rust. Multiple, yeah. So I just expect someone beat me in my face for this question, but yeah, for sure I can split them. So why? So yeah, for the tuple or for the like structure like this, yeah. In the same value. Yeah, it does allow you to have mutable references to non-overlapping parts of the same value. But the problem that we have the same thing here. We have a data and worker process. How to wait and send and write data to a process at the same time, Rust. So why it's so like sleep in thread? Yeah, this is kind of easy. So since we're using here async move, we just can't use this data value outside of this task. We just can't do this. It's just not possible, you know. But what happens if we do thing like this? Okay, that result option. Result access status. Okay, much. So I would like to try like this. So I guess if this won't stop, like won't block, so this would be fine for us. I just don't know if it's like legal to use like this. Oh. What? Oh. Wait, we can't do like this. We can't go wait. Oh. This is kind of interesting. So, we can't call wait at all. So if we call wait, let me reduce slightly this loop. Why it's compiling every time? So I should have yeah, so should be everything should be here. Decon charge, thanks for following and enjoy the stream. This is kind of interesting. So I have I override like library, path to store everything like compiled thing from Rust, so it's located in my cargo path. But I did this because so if you have a lot of small folders in a project, they always cost you a lot of space on a hard drive, like a gigabytes of space. You know, if you have a lot of Rust projects, like I do, like algorithms, Rust playground, like different things, so they cost a lot of gigabytes. So I decided to put them into one basic space to easily nuke. But I don't understand why Rust compiles every time all this test, since nothing changed in it, you know, as you may see here. So basically nothing changed, so it already should be compiled. But yeah, so what happened here? I don't understand. So actually, if we call wait, here, so Rust returns us an error, but why? Exit status, like something weird. Why? And we can check. Yeah, we don't have any PHP. So okay, at this point we should have a PHP script running. Yeah, so here you are. And if we call wait, so defunct. So basically, as you may see here, this is zombie process. So zombie process means that we have a parent. So you know, like we have a parent, and parent have inside it process table, like child 1, child 2, child 3. And basically, if you call wait for, so wait for system call is designed to delete these entries if process exited, like child process exited. Or, for example, if parent dies, all of these processes will be moved to the PID1, like our init. So they become like childs of the PID1. And to prevent zombies in our city, you know, you should call wait for on every process, on every child allocation. And as you can see here, you just can't kill the zombie because it's already dead. So even if you shoot it in the head, it will be alive. But as you may see here, now we called wait, and boom, it disappeared. So nothing inside our parent process table. But this is kind of interesting to me. Like, why? So why, if we call wait, this leads to like process termination? So this is something which should not happen, you know. Self pipes. So we can use so this is kind of interesting. Wait, process Rust. Let's read the documentation. Oh, super nice documentation. If you like to wait child to finish, you must call child wait. Yeah, very helpful. Oh, methods wait. Waits for child to exit complete the status that it exited with. The function will continue to have the same return value after once the stdin handle to the child process, if any, will be closed before waiting. This helps avoid deadlock. Yeah, so guys, I guess we have to implement a wait for syscall by ourselves. So because it like this is not the same wait as I guess in Go. Let me check the documentation about Go wait. Must be called this process incomplete. Yeah. Oh, this is our, yeah, so I reading our documentation. Yeah, so in Go, this clearly states that if any of our file descriptors like stdin, stdout, stdir are not OS file, which can be on Windows, I guess, because on Windows the wait works slightly different. Wait also wait for the respective IO loop copying to or from the process to complete. So yeah, so in Go, if you call wait, this will not lead you to like the code close to stdin. Block until waitable, yes, syscall wait ID. Yeah, so we have basically syscall 6 in Go. You can use like wait ID with speed, or you can use this is the previous one, and you can use wait for basically directly. And I guess so we have to do it like in Go wait. In this case, when we start a process, here in pipes, we would be able to do things like this: self child bid. Where is it? Where is it bid? So this is kind of interesting. They don't have a bid. Or it's like ID. Oh, it's ID. And it's only on command. Self child ID. Yeah, so called ID. Yeah, this is kind of strange decision to call it ID. And basically we can get, you know, for Windows, for basically for every platform, we can get this ID. And we might add this ID here. ID is U32. And we can basically save it here. ID is equal to command ID. This is an option. Okay, like this. In this way, if we save this ID, we can use, I guess for wait, we can use a self, because ID, so if you use U32, it will implement copy, so we can just copy it, because it's like a primitive type. This is called in Rust.
Everything from your weight to your BMI. None of your business.
Okay, ChatGPT. It's now time to shine. Wait for system call in Rust. Yeah, basically, wait speed, as we saw earlier, uses Go, like here. Wait ID actually. Mix. Oh yeah. Okay. Stop generating, please. I don't want. I want to use only stdlib. So yeah, I can do this. I need. So you waste a lot of. So you can waste a lot of time just explaining that you want to have from ChatGPT, instead of just Google this for like a few minutes and find the answer. So okay. Hello, Yoma. Yeah. Yeah, sure. So we can use libc for sure, but libc for us, I guess in this case, we have to. So, did I ask about fork from ChatGPT? No, I didn't ask about this. I asked only about wait. Why ChatGPT explaining me to how to fork? I guess because it's like, just copying and pasting some kind of documentation, some like obtained somewhere. So yeah, basically we need this wait speed. And since we would have a PID and we would have a status actually, by the way, where is the status? Oh yeah, so yeah, status. Status is means a status code, and yeah, so basically we need only this. with status, for sure. Okay, and yeah, we have to do something like Linux dependent at the moment. So we have to depend on libc. Libc is like 0, and on Windows, okay. What about Windows? And while it writing, we can just use this sample. Okay, so in this case, if we use libc, we can basically do like ChatGPT suggested us to do, like use status like which is equal to 0, and then wait. Why we are not using like wait for, but wait pid? So I guess wait pid, but we have man wait. Oh, yeah, so they are POSIX compliant, but wait for might be not. Yeah, this is a BSD style. Oh, yeah, now I get this. Yeah. So these functions are non-standard in new programs. Use wait pid or wait ID. So basically, Go uses wait ID. Yeah. Yeah, so they are non-standard, so this man clearly states that we should use like wait pid. And ChatGPT like also like wait pid suggested us to use. Okay, wait pid, and since we have pid self if self ID is basically if let some ID is equal self ID ID and mutable status. And so I guess they ask me to use unsafe, like C. Add unsafe to function. Yeah. Pub unsafe. We can't. Oh, this is not an async anymore. And result, let's just temporarily turn off this. Okay, so and what are you arguing for? PID-T as PID-T as libc PID-T. Yeah, so basically this is how we can do this wait, but this adds an unsafe to our code, and I don't want to introduce unsafe. I forgot. Yeah, we can do a wrappers. We can write like wrappers, like safe wrappers to call an unsafe function, but if we call this function in our RoadRunner Rust code, like here, oh, and we have to implement this. Oh, yeah. So we have to implement this function to call it not on a structure like here, so not on self. We need to provide an ID here, ID u32. Oh, yeah. let it be u32, and do like this. And get this function out. So basically it's already out of this pipe structure, but I don't want to mix them, and let me see here, like unsafe weight. So this function will definitely block here, and basically we can implement this logic, but I'm still thinking that I'm doing something wrong. It's not a Rust way to do things like this. In Go, this will work, I guess, and definitely work without any problems. And in Go, I don't know, do we have some kind of problems calling wait like this? I don't know if it's like even possible to get some kind of condition here when you call two mutable status at the same time. I don't think so. I think that adding, I don't know. I actually don't know how to do this in a Rust way. I guess. Hello, Rebelator. Nice to meet you and welcome to the stream. Enjoy. I don't want to do like this. Actually don't. So this is a last option to me to use an unsafe. I do like unsafe in Rust, so this is kind of fun. And we when we start to writing and SAPI in Rust for the PHP, we will use a lot of unsafe, because this is kind of very low level of the integration, and we have to wrap all of these unsafe functions into the safe abstractions, like, and produce a safe API. But here in this place, when we need to call PID only one time, so can we do this other way? Actually, we can't call wait. Yeah, so they drop. Like, let's see how it works. Wait, exit completely status. Yeah, so this is definitely the reason. So imagine a case. So why they close stdin? So if we just send or receiving a data, like for example sending, they refer to stdin. So helps avoid deadlock. So if currently child is blocked on a stdin, for example, in this case, you just can't call wait in this API, and that because they close stdin. Oh, if the caller wishes to explicitly control when the child is still handled, they may take before calling wait. Oh, so yeah, as you may see here, the std. Yeah, so we definitely should. Okay, so let's do the following. Since we can since we can do the following, we can just get not only child here, you know, we can get the following instructions here. We can get pub std in, which is option child std in. Okay, process. Okay. std out and stdr. std out and stdr. No. Yeah, like this. And like, don't use a child at all. Yeah, so we can just leave the child here, but we can take, as this documentation states, where is the documentation? So since they dropping the std in and like taking this, they can take option, you know, and option can be none. And we can take this as they states in the docs if the caller wishes to explicitly control when the child std in handle is closed, and we want to do this, we want to explicitly control this. We can get this std in out of this field with take, and in this case they will wait for this function. Okay. But how this help us? So still we won't be able to block on this. Maybe they can like block on this function. Okay, let's see. So I just wanted to move out all of this stdr, stdin out of this out of the structure. Child stdr, and here we can do like this. Like std in is command std in, yeah, they std out, command std out, stdr is command stdr, like this. But in this case, use of mode value, yeah, okay, so we won't be able to use a child. Yeah, so and this leads to a situation if we can't use a child, actual child, or not only file descriptor of this child, we won't be able to wait on it. Like, yeah, we won't be able to kill it. Still, we can use like wait pid, or I guess kill, yeah, like kill pid to kill this process by its speed. But this is not the same as using as using actually the child. And interesting question. So basically it will work only to send and receive the data. But we can't. Okay, so if we want to use an ID here, so maybe a command like stops us from passing this child. Option child. Child. And okay, let's try. Yeah, this is not an option. Okay, so this is not possible. Yeah. Which doesn't implement copy trade. Yeah, and since we are using like since we are using a command here as well as here, so this is why in Rust, you know, you have to think a lot. So if you implement your API in the wrong way, so you make one little mistake, especially at this such kind of low-level API, it will nuke everything in your application, I guess. If you miss this concept of borrow checker, because here, if I missed this wait function, and basically this how it works actually, and basically this ruins all of my API which I designed here. So I guess everyone who wanted to start working in Rust have to change their mind to think slightly different, I guess not slightly but significantly different, because there are other languages like Ada, for example, or like so different languages that uses also, I guess from the Microsoft they try to design some kind of Rust similar language which also use a concept of borrow checker, of borrowing of lifetimes and like all of the things. And so in popular and modern programming languages I never saw all of this kind of stuff. So okay, we either can do our child, and if we use child, if we like use std in, std out, and stdr, what advantage gives us this decision? So nothing basically. So we can't use wait, we can't use kill from the child. We would still have to implement our unsafe functions, and this is not leading us to a solution. So that was a bad decision to do like this. And like this. What? Nothing. I can do like this. Interesting. So, oh yeah. First of all I should call command ID, and only then I should assign. Yeah, so this is like, you know, kind of tiny difference here, but kind of important. So basically, from the point of view of the process, we can do something different. So this is just how it works. We just can't. So if we want to use a wait, we have to use wait. Oh, I'm sorry, not wait, async. Oh.
How do you want to do that?
okay, ChatGPT, it's time to shine again. Oh, as we see, this is how much work we have to support to do this on Windows. Create. Oh, so this is mostly about create process. Yeah. So this is create process. We don't need this one, I guess, on Windows. And unsave. Wait for signal object. It can be more verbose, you know. Wait for single object function from the sync API. So this is also very nice and understandable return error codes from Windows. You see, like in the hex format, like instead of just returning -1 like in Linux. So if you have -1, you have an error. So it's obvious. So on Windows, this is kind of problematic to support. I don't want to do this. To support this even for Mac, but but in Go we also support a FreeBSD, so this is also I don't have a FreeBSD at all, and this would be super hard to support and implement for sure. But okay, you have to ask question from ChatGPT, but I don't know what to ask. Basically, I don't know how to ask to, like, because I know this is impossible to have two mutable references at the same time. So how, like, okay, let's see the Go documentation. Golang, wait process. Like 4 methods. Yeah, wait, this is a blocking one. This is also blocking one. Yeah, this is non-blocking one. In this case, this is kind of in Go you have options, you know, options not in like data structure options, but you have options how to do this. In this case, this would be safe to do like this. So it will like wait here some time until this process exited. You can put this. Oh, what? So yeah, in Rust we even can't do the pattern like this. We can't bring this pattern from Go. So since we have channels in Rust as well, but we just can't block on this case because we still need to use this command outside of this function. Yeah, summary. Yeah, so in Go it's kind of easy. It's not even a question in Go how to do this, because it's obvious how to do. This is not a problem at all. So basically the question is how we should revisit this API to support the following operation. First, to start a command like this. Second, wait for the completion of this command in a different thread or task, or I don't know, anything which executed asynchronously. And at the same time, point number 3, execute the payload on the initial data structure. So how can we do this in Rust? I don't know. And every sample in a book like states, okay, let's use a cycle, a for loop in a different threads. Like, yeah. So this is clearly an I guess so. From my point of view, this is not a Rust way somehow. So we just copied code from Go in a Go way, which is not a Rust way. And in this case, okay, so how to write this in Rust way? Since we can't do this operation in a different task, because in this case we have to move it. Only unsafe, I guess, so, or the only unsafe and only implementation for different platforms, you know. So or we can skip waiting at all. And okay, so we have okay, option number 100. So we have we might also skip the waiting here and assume that everything is fine all the time. And in this exec function, we might self pipes child. We can check an ID, for example, but this is kind of, you know, this is kind of very inefficient way. And we also can't use this stdr, stdout, and stdin, these three file descriptors, because if we called wait, so Tokyo immediately close our stdin. So before calling wait, we have to like in this place, we have to do like this: self pipes stdin child stdin take. Like this. But in this case, if we will try to send something into the stdin, obviously it will result in an exception, or in a panic, or in an error, so whatever we want, because we just took and like stdin for our child. So when someone tried to like use it, option would be none. And we can't use like the separate field in our like, you know, here. Oh yeah, but might be we can. Okay, so let's try the following. Okay, I have an idea. Yeah, so if we, where's it? Where's my code? I have to, where's this take? I have to remove it. Where are you? Take. Oh yeah, here you are. So the idea is the following: if we can't remove the pipes out from the process, we can do this here, like this. let mute stdin is equal to p child stdin take. And basically we can this way extract our file descriptors and use it like here, like stdin is option child stdin Tokyo stdout stdr stdout like this, Tokyo and Tokyo, and here we also can assign a PID p child ID p child ID is none if then it would be an error. Let's use our famous IO error, which is not an IO error. String from p is none. And here we will be able to do like this: child ID unwrap. Oh, it's U16. Oh, U32, like this. And next, stdin, stdout. Boom, like this, yeah? U32. Okay, fine. It's surprising. It will would be surprised if it compiles. Cargo build. Nice. It compiles. Yeah, I can use like this. Thanks, Clippy. And in this way, we take the responsibility of all of these file descriptors to our code. But still, we won't be able to use child simultaneously. But we don't have to use them. We extracted it. Okay, so okay. Send.
It was like a terrible nightmare.
Yeah, in this case we have to implement all this stdin child send. So yeah, we have to do by ourselves all this kind of stuff. We can't use pipes anymore here, because pipes actually don't have anything, any file descriptor actually, because we extracted all of them. Okay. So in this case, yeah, we have a lot of code here that we should like re-implement. So in this case, we have to move everything to our worker. But what? Okay, so fine. We have std std.stdr. And now, if we try to let me just try. A lot of like unused code. Now await should block. Let's see. Yeah, as you may see here, await blocks. And this is what we expected to see. Okay, so await blocks. This is basically the same as we might have with just calling wait, but now. So yeah, this is also road to nothing, because still data is mutable across the threads. Yeah, this won't help us. Okay, so I also know one interesting feature in GitHub. Let's use search. What is the name of this? Okay, this is a command. So let's try to find everyone who uses a process. Command U, and see and see how they work with wait. And we need. Do we have a Rust? Rust. It's not a Python. Ruby, Go, Swift, so everything except the Rust. More. Java. Yeah, similar to Rust, Java, you know. GitHub. So you're completely broken. I said Rust. Oh, now I see. And let's sort by we don't have popularity. What is the name of the file? src env command rs. src env command rs. Um, mm, 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 mm. Command arcs. Oh, okay, so this is definitely what we want to achieve. So, surprisingly, we have found a solution. Okay, let's see. So, here we have a child process, you know, and we are receiving a just standard child. This is not Tokyo like we use, but we also, for sure, we can use a standard child, so this is not a problem. And then we have child std out. So this process child is basically the same as we use here. This child, but our child is Tokyo process, but we easily can swap it with just a standard one. Okay, so we have two childs. They have channels, and okay. So why this should block, I guess. This is not an async function. Change it out while also collecting the result of the process. Yeah, so they would be like, they would read continuously from std out and stdr like into the error print line. This is the stdr, and just regular print line is for the just std out, you know. And here would be the blocking function, but we wanted to do like vice versa the thing. We want to use child wait on this one. Okay, so this is kind of interesting. So this is possible. Might be our problem is that I use a lot of Tokyo, and I should use an just standard library. Okay, let's try this approach. We just need to write everything we wrote with the help of Tokyo. Why not? So that's why this is so hard. It's not so hard, but it's like time costly to prototype something in Rust. So when you prototype something in Rust, so this is definitely would cost much more time than if you try to do the same in Python, for example, or in Go, or in any like other programming languages. Okay, so child for us here would be our not but a standard child. All of our functions won't be async because standard process is not async. Oh, and this is not an option. So I guessed why it's hidden under the option. So because speed is already known, and I guess due to async nature of Tokyo, all of the things, they just don't know a PID at the time when we fire a process. So some kind of concurrent things executed at the same time on this Tokyo command. And in this case, yeah, so this is kind of understandable. Yeah, so write all function is not an async. Yeah, so we don't need to use await. Yes. why we started yeah, so why we started to use an Tokyo, because of this timeout function. So timeout function doing this the following. So if we blocking on, like for example on where is it, like std out, yeah, if you're blocking on std out, because for example process started to send us some trash, not our frames actually. And if we're blocking on this std out, we have to wait a little bit, like 2 seconds in our case, and kill the process. So we don't want to deal with such trashy process. We just need to kill it. But we have to preserve the buffer which we already read from this process during these 2 seconds. So we have to hold it. And I guess we basically can do the same thing, like thread std spawn, and here in the thread we can do the following. Move we have it. Oh yeah, we also buff reader we should use not from Tokyo but from the standard library. And buff, yes, not wait, this is not also wait, this is not an async function anymore. Read exec. Yeah, so we have to import this method, and now we have to do this thing, but without a timeout. Yeah, we should, I guess, unwrap, but this could panic actually. Child, yeah, we should also import all of this, like re-import. And yeah, here we also don't have a wait. And this function we also not async, so we're just moving out of async. And just unwrap, just like this, and this one. We don't need this, yeah, and yeah, this one. This one. Yeah, and self-control. Can I try? Yeah, to the future. Yeah, this is also not an async function anymore. Yeah, and here we are. And now our task is the following. We have to somehow so buried data escape outside. Yeah, so we use a buffer here. We should be able to use this buffer outside of this thread function, outside our thread that we spawned here. Why? It's because, so if we're like let me just, so buff message let's replace with foo. Okay, still error. Buried data escapes outside of switched function. What type of buried data? Cargo build. Self. Oh, we use self, or we use self. Okay. Yeah, oh, I'm sorry, I just, yeah, we should use this like this, thread code, yeah, and then, yeah, let thread is equal to join handle, and we should like join it and wait for the result. Okay, so basically we can so since we can't return anything from the thread, we can use a channel to return this data from a thread out of it, like in Go. You know, so this is not important, part of the code. This is not a high performant. If we can't verify CRC, this is definitely an issue. So this is so I never, during the whole RoadRunner development period, like 3 years, I never saw any of verify CRC errors which was not serious actually. So every CRC issue lead to a serious problem. So you have like incorrect configuration, you have like PHP ini set up incorrectly, they produce some values into std out, and etc, etc. So this kind of important problems which we have to report. And in this function, on the first place comes like observability and logging. So we have to log properly everything that we can get from this process, you know. And so this is not important that we can wait 2 seconds. So 2 seconds is so much in terms of high performance applications, you know. But I can't understand what is of this data is Oh, move? I don't oh yeah, we have a buffer. Yeah, so okay. We have a buffer which definitely escape. Yeah, and see at these beautiful error messages, like, you know, may outlive borrowed function value buff. Buff is borrowed here, like buff is borrowed here, and self. Oh yeah, so this is so beautiful error messages. So okay, self adjustment is normally shared lifetime 1. We don't have self. We have only buff. Yeah, and the problem that we have self here, not as an incoming argument. Okay. We can do this in a reverse way, like this. Okay, we can read this, but first, oh, let me take a picture. But first, we can do like this. Let sleep is equal instant, not Tokyo, please. Instant, instant. Like what is it? Oh, thread sleep. STD thread sleep. And let's say let's sleep. Oh, not instant, duration. Duration. Default. Sleep. No. How to specify duration? Oh, it's like I know. Let. I guess it inside an instant. Okay, how to Rust? How to sleep? Yeah, so stupid questions. Oh, from okay, so time. Oh, they have time. Time. Oh, this is from libc. Yeah, so let me remove libc since we don't need it anymore. And let's use std thread. Where's our thread? Use std thread and time. Okay, nice. And time duration from seconds and 2 seconds. Nice. And now we don't need this anymore. And after 2 seconds, we are going to kill this process. And since inside self we have an ID and ID is copy, we are allowed to do this. Okay, so let's how we can kill this. child. Oh yeah, we should sleep. Sleep and sleep amount of time. And our next self child heal. And we have to use, I guess, move. And we are not able to use child anymore. Where that escape from a sheet function. Where are you escapes? Where are you escaping? Oh yeah, so we are not we are still reading from a buffer here. Yeah, so okay, fine. We're not allowed to use this. Thread sleep, and then we are joining in a different thread. Yeah, so this is stupid. So we should be able to read the data. Okay, so let's do like this. Thread, join, and wrap. So in this way, no, this is, oh, still we have to use some kind of see kill or wait. So at this point we are getting an trash. Okay, fine. So we have an trash here. So we have to read till the end. So this buffer is actually have our child inside it. So we can't use buffer outside of like child, and we can't use self because self borrows this thing. Yeah, so the advantage in this code, so this guy creates an buffer and with this child, inside the thread. So there's no need to to do something outside of this thread with this child stdr. Since he can take this outside of the buffer, but we can do this. We can, so might be we don't need to use as mutable here. We can take this option and then Works. Okay, so it works. Okay, so what we did here, we are trying to read to the end, waiting for 2 seconds, and self. Do we need this move? Yeah, since yeah, move, but we can't. Since we get std out of our, so since it's inside the buffer, std out so our std out get by this buffer, so we're not able to use self child kill like this. Oh, we can do like this. Come on. Yeah, great, awesome. So okay, so at this point we don't need to anything from this process. We just need to start it. So like this. We just started without waiting for the result. Then we are waiting for 2 seconds and killing this process. And the rest for us is to create a channel. So if when we exit from this process, we have to do we can't just use unwrap here. We just need to use match. We need to use this because we have to be safe. Remain patterns. Okay, this will definitely be an error. Okay, and error. I'm sorry, what it would be? Okay, number bytes of read. Number bytes. Yeah, so this is basically like in Go, number bytes read from. So in case of OK, we're not returning anything. But so in this, so this function won't be OK. I'm for sure because we're killing it. I'm sure in this. And this because we would have an error actually. Error with error code. We can like just log it to string like this. And which is more important for us, then we would be able to access this buffer here, you know? And this buffer we are going to send via the channels like this. Why not just copy this channel without? And the channels, yeah, this is kind of you know, fun stuff that channels have in Rust, like a receiver and sender part. Okay, so receiver. Oh, transmitter and like sender and receiver. And here we send our buffer. And here, like in Go, we are receiving our buffer. Unwrap. No, I don't need a buffer. Oh, I'm sorry, not buff, but buffer. Like this. Yeah. This is what I want to do. unwrap actually. I don't. Yeah, so this is kind of unsafe. We rewrite this. Yeah, and this is basically how it works inside Go, you know. So using the channels from the threads, and kill. We also. Okay, let's have this panic message, and basically now we have a data, and we can use it like this, and we can use our buffer message like this. What are you arguing for? Oh, it's already implemented display. Okay. Let's try to build it. Okay, and now let's try to test it. We actually don't need async function anymore, and we don't need Tokyo test, just only test. I think some function can like fail. Oh yeah. So everything works fine. Yeah, I'm right. One more time. Yeah. So this is hello. Actually, in our this is our frame, you know, and yeah. Let me just uncomment this line of code. So this line of code forces to produce an issue, and we should get here. Let me check this. Should wait 2 seconds. Then kill process. I'm waiting. I guess we don't need to use a join. Where is it? Yeah, we don't need to use a join. Nice. Some PHP. Yeah, some word PHP error. I'm the king. Yeah. This is exactly what we are wanted to achieve here. So we don't need handler here, because actually we want to start this spawn this thread in in the background. So we don't need to check it in any way, and it will exit after we finish this send operation. This is slightly more code than we have in our initial implementation. Here, yeah, as you may see here with with Tokyo, this is much more simpler to do. So we just need to use a timeout function, which is under the hood starts this spawns a thread and you know, doing particularly the same which we did like manually. And but since it's async function and why we did this change actually? We did it basically to have a standard command here. But as far as I understand, while I implemented the things, we actually don't need to have a standard command here. So we don't need to have a thing like this. Standard child, you know, because actually, since if we can take something out of our std out, this will not lead us to an error, because if we use as mutable like this, immediately, as you may see here, this produces an error. Because yeah, so I understand now. So yeah, I got a vision of this thing. So if we use as mutable, we are not getting the ownership of this std out to our hands. We're just using an mutable reference to this std out, and this is not possible to do in this case, while we're using self, actually self, and the buffer here, because we have two mutable references here. And if you use take just get out this std out, getting out std out from the child without taking ownership. So now std out, now child std out is none, so nothing in it, and we are responsible to have this std out. But which is more important, if we try to receive std out the second time, this will lead to error, because we get so we already get this out of the std out and didn't put it back. So at the end of OK function, we have to, I guess, do like this: std out is equal to std out. So I guess we should do like this: use of mode value. Yeah. So yeah, another problem. So we should put it back in some way, because in this case we won't be able to receive the second time, because take moving out of this. Yeah, as you may see, sum to take as equal none. Yeah, so it will be none, and we have to put it back. We have put back what we get. And this is why this code works fine, because actually std out, child std out here, and child std error actually didn't attach anymore to the child. They are out of it, and thus we are able to use child wait and thus to think these two things in a different thread. So yeah. Okay, lesson learned. So now we are able to might be, so I guess on the next stream I'll be I'll return back our Tokyo implementation and try to take the std out in the RoadRunner Rust here. So where is it? Where are you, worker? Yeah, I'll try to take the weight or things child yeah, so we have to take out child but leave std error, std out, and std in, and in this case I guess it would be the same kind of difference. So we should think about this. Okay, but this will be on the next stream, and now thanks everybody for watching, and have an awesome evening, and see you tomorrow, guys. Bye bye.